Hi, my name is Steven Scheidt, and today I want to talk about how the Tesla car battery works. Tesla was founded in 2003 by a group of ambitious engineers who thought that electric cars would not only be more energy efficient, but just and better for the environment. The commonly known Elon Musk joined the board of directors early on in Tesla's development to oversee production of this newly thought idea and even helped with the production costs through many investments. In 2008, Tesla first released the Roadster, which showed off the Tesla's amazing electric battery package. And now in the year 2020, Tesla has a multi-billion-dollar company, is as popular as ever, and sells all sorts of different models, such as the Model S, the Model X, and the Model Y. To introduce the idea of how a Tesla battery works, I want to start off by first defining what a battery is. So, a battery is a device that consists of three different parts. If you look at the top left picture, those three parts are a negatively charged anode, a positively charged cathode, and an electrolyte solution in the middle. And what a battery does is it turns chemical energy into electrical energy using a process called electrochemical oxidation reduction, which I'll discuss in a later slide. Batteries are used for many things, as we know, such as powering up our flashlights, our phones, obviously our cars, and has very many applications. Now that we know what a battery is, I want to talk about the chemistry behind a battery or how a battery works. So as you can see in the picture, like I mentioned before, there's the negatively charged anode, the gray bar in the middle is the electrolyte solution, and then the right side is the positively charged cathode. So what happens is electrons will travel from the anode through some sort of conduit, in this case a wire, um, from the anode to the cathode. And there will be some sort of external source, in this case the light bulb, that will be powered from these electrons flowing, creating electricity. And if you look at the picture on the left, this explains how the oxidation reduction reaction takes place. So the oxidation usually occurs at the anode part of the battery, and oxidation is defined as when a metal loses its electron, usually in the battery's case, some sort of metal, in this case zinc. The electron will travel from the anode to the cathode and then combine with the substance that will be reduced, sometimes in the solution, usually with, in this example, copper. As the metal at the anode oxidizes and loses its electrons, the battery starts to lose its power and will eventually die out when no more oxidation can occur. However, this can be reversed through charging. The process of plugging in a charger with an outlet or other module allows this oxidation reduction reaction to reverse, working in the backwards direction. This will send the electrons back from the cathode to the anode, helping the metal become ready to be oxidized again. To think of this in a conceptual way, you can think of when charging through a power outlet, for example, electrons are gaining potential energy or moving to the top of a hill. When fully charged, they release their potential energy and the electrons flow back down the hill, providing this energy to send electrons from the anode to the cathode and providing an electric current. Now that we know the basics of the chemistry behind the battery, let's talk a little bit more about the batteries in the Tesla. So the Tesla is really no different. The only difference is the type of battery it uses. Historically, there have been two different types of batteries, the first being the 1865 and the second being the 2170 battery. These dimensions refer to length in millimeters. So in the 1865's case, the 18 millimeters is in diameter and 65 millimeters is in length. And in the 2170's case, the 21 millimeters is the diameter as well, and the 70 millimeters is the length. One is not necessarily better than the other, but Tesla had noticed as they used the 2170, the charge rate was a little bit faster and the lifespan of the battery was a tad bit longer. Now I'm going to talk a little bit about the setup of the battery in the actual Tesla car. So when you look at the picture on the bottom left, you can see that one battery is defined as a cell. A combination of around 70 to 80 of these single cell lithium ion batteries are all connected in various patterns of in series and parallel to create what is called a module, that middle side. The amount of modules differs from model to model, but generally 16 models make up what is called a pack. By doing the math, we can learn that there are approximately 7,000 cells or lithium ion batteries in the whole vehicle. These packs are placed at the bottom of the car to provide structure to the vehicle, and they also have tubes that pass something called glycocoolant through the gaps in between each cell that prevents the batteries from overheating and losing its function. The pack is then connected to a radiator at the front of the vehicle, shown in the top right picture, which will allow heat to be released out to the environment. As I mentioned before, the Tesla's battery is not all that different than a normal battery that we see and use every day. The difference is mainly just in the composition of the anode, cathode, and electrolyte substance. The cathode is usually a graphite substance, mainly made of carbon, and the anode is a different amount of cobalt depending on the model type. In the Tesla's case, the cobalt is what's being oxidized and losing its electrons, and those electrons will travel towards the graphite cathode. The lithium ions switch directions depending on if you are charging or discharging the battery. Finally, before I conclude, I just wanted to add a picture of the different types of models that the Tesla has come up with throughout the past decade or so. As you can see, the first one was the Tesla Roadster in 2008 to 2012, and then they came out with the Model S in 2012, then the Model X in 2015, and the Model 3 in 2017. And this picture over here to the left shows a lot of different things, such as the power of the battery and the engine increasing from year to year, the price increasing and then decreasing again. Luckily, Tesla is becoming a lot more cost efficient throughout recent times. Yeah, and I will go ahead and conclude now. In conclusion, this idea of using an electric battery and a rechargeable battery in cars has been revolutionary. Tesla has sold over 350,000 different types of models just in the year 2019. The Model 3 has become the world's best-selling plug-in electric car battery, and Tesla is doing big things, and electric batteries might be the future for the car industry. Thank you for watching, and go ahead and subscribe.